Good morning, students. This is Vijaya Janardhan Ushir, working as Assistant Professor in Department of Chemistry at Maratha Vidya Prasarak Samaj, GMD College, Sinnar. In this video lecture, we will study the first topic of your physical chemistry course, that is chemical kinetics. So, what is chemical kinetics? So, chemical kinetics is the study of rate or speed of the reactions, such as the way reactions takes place. So, chemical kinetics is the study of rate or speed of the reactions. So, rate of the reaction is given by decrease in the concentration of reactant divided by the time in which the change takes place. And in other words, rate of the reaction is given by increase in the concentration of product divided by the time in which change takes place, because as the reaction proceeds, reactant get converted into product, so concentration of reactant get decreased and concentration of product get increased. So rate of the reaction for in terms of reactant is given by decrease in the concentration of reactant to which the time in which change takes place, and increase in the concentration of product to which the time in which change takes place. So unit of the rate of reaction is given by concentration of reactant, means it is concentration is explained in the term of moles per liter. So unit is moles per liter, and what is the unit of time? Unit of time is the second. So overall unit is moles per liter or dm cube per second. So unit is moles per liter or dm cube per second. So if we plot the graph of concentration against the time, then we can see here that here is increase in the concentration of product, because here is decrease in the concentration of reactant, because when reactants get converted into product, the concentration of reactant decreases slowly with increasing time, and simultaneously concentration of product increases with time. So as the time changes, the concentration of reactant decreases and the concentration of product get increases. This is the graph showing the progress of this reaction. So for any chemical reaction, if A moles of A plus B moles of B gives C moles of C plus D moles of D. So average rate of reaction R average is given by minus 1 upon A delta A upon delta T. Minus 1 upon A, that is stoichiometric coefficient, or and minus sign indicates that decrease in the concentration of reactant. As the reaction proceeds, concentration of reactant decreases, so it is given by negative sign. So minus 1 upon A, delta A and delta T. What this delta A and delta D denotes? This denotes the change. So there is change in the concentration of A, and also there is change in the time. So it is given by delta A upon delta T. Also in terms of B, it is given by minus 1 upon B, stoichiometric coefficient minus 1 upon B, into delta B upon delta T. Delta B means that is concentration of B also changes and time also changes. And in terms of product, it is given by positive sign, because in the products concentration of product increases. As the reaction proceeds, the concentration of product increases. So given by positive sign. So 1 upon C delta C upon delta T is equal to 1 upon D delta D upon delta T. So rate of the disappearance of A is given by minus delta A upon delta T. So rate of disappearance of A is given by minus delta A upon delta T, because concentration of A decreases, and also rate of disappearance of B is given by minus delta B upon delta T, and rate of appearance of C is given by delta C upon delta T, because concentration of C is the product, increases, so it is given by plus sign, delta C upon delta T, and the rate of appearance of D is given by delta D upon delta T. So next point is order of chemical reaction. So what is order of chemical reaction? The order of reaction is refers to the relationship between rate of the chemical reaction and the concentration of species taking part in it. So in order to obtain the order of reaction order, the rate expression of a reaction in a question must be obtained. So order of reaction can be defined as the sum of the power dependence of rate on the concentration of all reactants. Means it is the sum of the power of concentration of all the reactants. It's called as a inner rate equation. Sum of the powers of concentration in a rate equation is called as a order of reaction. So for example, the rate of first order reaction is dependent solely on the concentration of one species because its name indicates that it is a first order, means first means depends only on the concentration of one species. So some characteristics of reaction order for a chemical reaction are listed below. So reaction order represents the number of species whose concentration is directly affecting the rate of reaction, and it can be obtained by adding all the exponents of concentration terms in the rate expression. And the order of reaction does not depend on stoichiometric coefficient corresponding to each species in balance equation. This stoichiometric coefficient, as we have seen earlier, small a, small b, this stoichiometric coefficient. So order of reaction is independent of these stoichiometric coefficients. The reaction order of a chemical reaction is always defined with the help of reactant concentration and not with the product concentration. This is very important point. The order of chemical reaction is dependent on reactant concentration and not the product concentration. And also the value of order of reaction can be in the form of integer or fraction, and it even have a value of 0, means order may be 0, may be integer or a fraction. So determining order of reaction. So for this reaction, how to determine order? So A moles of A plus B moles of B gives C moles of C. So rate of the reaction is given by R is equal to K into concentration of A raised to A and to concentration of B raised to B. So here R is the rate of the reaction, K is the rate constant of the reaction, and concentration of A raised to A means concentration of reactant A, concentration of reactant A with the power raised by the coefficient. So what is the coefficient of this reactant A? That is small a. And what is the coefficient of this capital B? It is a small b. So B raised to B means concentration of reactant B with the power raised by its coefficient. So order of reaction is given by A plus B because it is a sum, it is the power raised in the concentration of reactant. So power raised is A and B. So sum of these powers is A plus B. So A plus B is the overall order for this rate equation. So next point is the molecularity of a reaction. So what is the molecularity? Molecularity is the number of reacting molecules collide simultaneously to bring about the chemical reaction. So for happening any reaction, how many number of reactant molecules are colliding simultaneously is called as the molecularity of that reaction. In other words, we can say that molecularity of an elementary reaction is the number of reactant molecules taking part in the reaction. So consider for example H2 plus I2 gives twice HI. So for a complex reaction, the order and molecularity is same, and the order with respect to each reactant is equal to the stoichiometric coefficient in the chemical reactions. In this reaction, molecularity is 2 because how many reactant molecules are taking part in the reaction? H2 1 molecule and I2 1 molecule. So molecularity is 1 plus 1, that is 2. So molecularity is the number of reacting molecules that collide simultaneously to bring about the chemical reaction. So next point is a specific rate constant. So specific rate constant is the proportionality constant relating to the rate of the reaction to the concentration of reactant. And the rate law and the specific rate constant for any chemical reaction must be determined experimentally. So value of this proportionality constant is relating rate of the reaction to the concentration of reactant, and the rate law and the specific rate constant for any chemical reaction must be determined experimentally. The value of rate constant is temperature dependent because the rate constant is very important factor. The rate constant of a reaction is always temperature dependent. As the temperature changes, the value of rate constant also changes. So rate expression. So we can see any square bracket. It means the concentration of that particular content. So here it shows the concentration of HCl. So we can say that rate is proportional to concentration of HCl and can be written in the form rate is equal to rate is proportional to concentration of X into concentration of Y. Thus, if we replace the proportionality sign by K is called as a rate constant. So what we got? Rate is equal to, this proportionality sign is replaced by K. Rate is equal to K into concentration of X into concentration of Y. So K is the symbol for rate constant of a reaction and K changes as the temperature changes. That is, the rate constant changes as the temperature changes. So overall rate expression is given by, so if we take into account the rate constant of a reaction and overall rate, then overall rate expression can be written as rate is equal to K into concentration of X raised to M into concentration of Y raised to N. So here M and N are the orders of a reaction with respect to X and Y. These are the M and N. These are the orders of reaction. And what is the K? K is the rate constant of a reaction. So overall order of a reaction is given by M plus N because order is the sum of the powers of a reactant concentration. What are the powers? M, power of X is M and power of Y is N. So overall order is M plus N.